Hello everyone. There are two versions for this project. One is called Speedometer version 1.0 Home and 1.0 Company. The differences are actually they are exactly the same here, but when you check the circuit board itself, it's a bit different. Like because for creating the PCB at home, you will have some difficulties in making the smaller traces, for example, smaller holes. They will be difficult to work with. Like for example, in this version, which is the company version, you see the drill is small and the pad or via is very small. Plus, we will have so many ground vias. But in the case of the home PCB, we don't have that many vias. I mean the ground vias. Now the next step is to export as PDF the home version, because in the company version you don't need to do this because you'll send the schematic to the company to create it for you. So we will remove the top silk layer and the border outline, and we'll keep the rest. Export, and you'll have this exported version as PDF. And we'll do the same for export PDF, remove the top layer and keep the solder mask. And remove the outline too. Export. So we need this version. And then export again. Remove the top layer. We want the bottom layer this time. And then remove the outline. Mirror, mirror, mirror. Export. We have this version. Again, export. PDF. This time we want the bottom solder mask. Remove the outline and mirror everything. Export. Right now we have all the exported versions we want. Okay. In case you cannot export them anyway, I will provide the PDF in the description. I will provide this version plus in A4 with 9 copies, so we can print them all together, because we don't know what will happen if we print one. We might have defects. For that, we'll print 9 in one piece of paper, a transparent paper. I used an HP laser printer and transparent paper for this print. Once we have the design printed out, it is time to cut and align 3 layers together. We do this to further darken the dark areas to prevent light from going through them. We first start with the top and bottom layers. Once we have 3 layers of each, it is time to align and stick the top and bottom layers together and ready for the next step. Now it is time to put the PCB between these layers, and make sure you don't have rough edges, because they might ruin the whole process. We will use sodium hydroxide as a developing solution. We will need 5 ml sodium hydroxide mixed with 500 ml of water. I will use a measuring spoon to take 5 ml from the container and drop it in the water bottle. Now shake the bottle very well to dissolve all the sodium hydroxide because that is very important. Now we have the solution ready for the next step. For this step, we'll need two flat glasses to support and sandwich our PCB. Now it is time to peel the PCB light protection and put the PCB between the layers and put everything between the two glasses. I used two tissue boxes to raise and support the glasses and put a UV light underneath the glasses for 2 minutes. Then again repeat the step, but this time hold the UV light for about the same distance for 2 minutes. Now remove the PCB and keep it away from light. Now it is time to put the PCB in a container and develop it using, in our case, sodium hydroxide. Be careful when using sodium hydroxide as it could burn your skin. However, with our concentration, it is not that harsh, but still, if it spilled on you, wash it quickly with water. And most importantly, keep it far, far away from your eyes. Keep shaking the container and check to see when the PCB is fully developed. This is probably one of the satisfying things to see when making PCBs. Once the development is complete, wash the PCB thoroughly with running water. If everything went smooth, your result will be similar to this. Now we move to etching the PCB, which is the process of removing the exposed copper from the PCB. I will be using ferric chloride for etching this PCB. This process is very similar to the previous one. Keep shaking the container until all the exposed copper is gone. I use light source underneath the container to help seeing the PCB. This is the final result after the etching process. All the exposed copper is gone and your PCB should look like this. And this concludes this part of our project. Thanks for watching and see you in the next part.